good afternoon, good morning, or good evening. So thank you very much to join us today for another industrial talk sponsored by IEEE Circuits and Systems Society Chapter Rio Grande do Sul and IEEE Calcium EDA Chapter Brazil, with also the support of UFRGS and also Brazilian Computer Society and Brazilian Microelectronics Society and ABSEMI. So today we have the pleasure here to have Eduardo Lima from Eldorado Research Institute. He has a large set of works in the Eldorado Research Institute. So he is a project lead specialist in the Research Center Eldorado. He's project design coordinator for digital transceivers and receiver, digital signal processing, wireless network, and implementation of these systems in ASIC, FPGA, RD&I, and on-embedded system. He has a PhD in telecommunication from Universitat Politécnica de Valência in Spain. He holds bachelor degree in electrical engineering from UNESP in São Paulo. And he supervises several postdoctoral researchers and constantly collaborates as a visiting professor at FEEC Unicamp, where he co-advises master and PhD students. He is also a productivity fellow in technological development and innovation from CNPq. So thank you very much, Eduardo, to accept our invitation. So now I give you the control to start your presentation.
Okay. First of all, thank you, Professor Reis, for the invitation. I was quite surprised during the WCAS organization of receiving our invitation. Thank you very much. Rafael, as always, thank you very much for your support. I just before I start my presentation, I just would like to mention 3 things that are not in my CV, short CV. But I need to mention that because they are important for my formation in microelectronics. Okay, the first one is that I got a 1-year period of training at IMEC in Belgium. I was an international scholar, a KU Leuven student doing research at IMEC. So I was an ideas partner in the previous ideas period. Okay, over there I started working with microelectronics in Brazil. I got a scholarship from the Brazilian Ministry of Science and Technology, and later on I became a partner. And later on, for some reasons, I need to leave the company. Okay. Basically, those are the things I need to talk before. That was not in my CV, but the idea of this presentation is not only present the technical stuff. No, a lot of you guys know quite well Eldorado. Some of you didn't have the opportunity to see our work. So the idea is, as we are covering a recent period of the microelectronics in Brazil, but it's a long period with a lot of things happening. So so this presentation is going to have a kind of historic background. Okay, this is the outline of the presentation. Basically, the first part of the talk is going to be, it's necessary to talk about the Eldorado Research Institute. I need to give an overview. I'm going to show some information at a glance. Okay, so we're going to show who you are, some numbers, our timeline, where we are, our main competencies, and some of our laboratories. Some of the laboratories, they are merged with the design house laboratories, but we have this independent lab that is the test facility for certification products. So I need to talk a little bit about it. So and then we move to our main goal here. That's the overview of Eldorado design house activities. Also, I'm going to show some numbers. I'm going to show the timeline of Eldorado's design house, followed by the presentation of our test laboratory structure. Also, I'm going to introduce our design portfolio. Of course, I'm not going to cover all the projects because I'm not allowed to mention some projects that we are running, of course, but most of them we are I'm gonna cover. So our design competencies are gonna be highlighted during this design during the presentation of our design portfolio. So then I will introduce our diversity package laboratory. Okay, that's a quite nice infrastructure that we are running at Eldorado right now. Then I'm going to talk about some exploratory projects. We're going to give some more details on our designs, okay? Because all these make part of our story. You know, it's there are some projects, there are some exploratory projects that they are long-term projects. They are like they are the base of certain projects at Eldorado. So they also use that to form people. So they are quite important. And then I'm going to talk a little bit about strategies, and we're going to open for questions, okay? So who we are? We are a civil association of a national range, so with non-profit ends, of course. So we are one of the top SCTs companies in Brazil, and best place to work. We are certified by some magazines, and we are also certified by CAT, Anatel, Screwman Lines. Okay, so we have all these business things and all this important certification accreditation to run our operation. Okay, so we are the #1 independent organization in investments under the Brazilian informatic laws and PADIs. So that's our vision. So we need to be focused on what we want. Otherwise, we're not gonna get it. Okay. So Eldorado's vision is to be the reference for the new technologies on information and communications and microelectronics. Our mission is research and develop solutions that are innovative, comprehensive, and competitive, and impact the society. So we are getting huge. So I think that right now we are about, these numbers are from 2019. This year, I believe that we are about 1,000 people, without counting the scholars, the guys with scholarships that are working with us. So we have 6 project partners. We have about in 2019, we got about $52 million in our R&D projects. So we developed about 142 projects. We have a 16K square meter facilities. Of course, again, we are the #1 informatic closet. Sorry. So Eldorado started its operation in 1999. Okay, we are getting old. We are this year we have 21 years, I think so, in 2020. So our first works on microelectronics was in the as a national ICT training, okay, a long time ago. So about 2000, we set up our large EMC lab, and then we start our this timeline's a little bit out of phase, okay. Our microelectronics process starts in 2012, 2002, more or less, okay. And then we start working at CPQD, and then later on we have this new building that I'm going to show you later on that we are running now. We have create offices in Brasília, Porto Alegre. I think Porto Alegre is completing 10 years this year or this week, okay. And then about 2016, we got this big expansion in our lab facilities to support the packaging stuff and prototype of other microelectronic stuff. Okay, so I think that's in 2018 we got this new office in Manaus. Okay. Okay, I'm still playing with this control. Sorry about that. These are our offices. Our main offices are in Campinas. So So we have this some offices, some floors in Manaus, Porto Alegre, and Brasília as well. In Porto Alegre, we are at Technopuc. Here in Campinas, we are just close at Unicamp. So as you guys cannot be here, I found some fancy pictures about our facilities, but the main goal here is not to show Eldorado itself. It just show where we are. Okay, at our surroundings, we have several important things. We are just in this street is the limit of Unicamp. We go to Eldorado through the Unicamp gates, but we are in the technological park in Campinas. So here at our side, we have this. I think that was the previous. The name of the company was PST. That a lot of people know that. I think that they were bought by Sony Regis, if I'm not wrong. You have some Unicamp offices, like Softex, I think so, and incubator. So here in the back, we have this Santander facility. It's a big facility around here. So São Carlos is around here in this direction. So here is, you can see, Facamp is on the top of this. If you go down on this hill, we have found a CPQD. We cannot go nowadays because it's close to the gate, okay? But it's about 2 kilometers from here is a CPQD. And the Catholic University in Campinas, it's here, is around here, okay? This is the technological park of Unicamp. Embrapa Informatics is around here. This building here is a new building of IC. This is an old picture, so these buildings are almost right down. So we have a new buildings here. So here again we have this that building, that's IC building. So here we have the main economy in faculty buildings, and the IC is around here, the computing institution. These buildings are they belong to the computing course of Unicamp. We are quite close. We are about 400 meters on the right here. Okay, as you can see, we are quite close to the very interesting area. So we are also close to the synchrotron labs. That's close to CPQD. Okay, we have a very nice neighborhood. That, by the way, I live around here, very close to Eldorado. So, as I mentioned before, so we are have certifications and partnerships. So we are NoCIP. We are an MBP unit. We are a Google partner. We also now can mention Apple. So we are have this Apple training center at Eldorado. Okay. So the main competence of Eldorado are related to cloud computing, data center, artificial intelligence, analytics, microelectronics, mobile IoT, visual computing, and imaging. But we have a lot of other competencies. They are the main ones that we try to group with in these groups. And our main the focus areas and service are hardware and software solutions. Basically, most of the people of Eldorado are working in these areas. So we have the innovation consulting area. We have the laboratory of testing and analysis. That's is for certification. And we have this unit for professional training, where among other things, we train people with some handicaps, and also train other professional people. Okay. So we have a world-class infrastructure. Is a kind of unique. So this in the middle is a full anechoic chamber. That's I believe that's the only one in Brazil, maybe in south below Mexico. Okay, we have some same anechoic chamber with the capabilities of having testing vehicles. I have this fancy infrastructure for training. That's the Apple Training Center. Okay, let's move ahead. Okay, now let's move on in our main goal. Okay, we cannot talk about the design house, of course, without talking about Eldorado. That's our mother. So we belong to Eldorado. So we are tight connected with it. So regarding the design house, I'm going to show some numbers. Okay, that's really important to show some results in terms of numbers. I'm going to show the timeline of our design house. I'm going to show the test laboratory infrastructure, our design portfolio, advanced packaging laboratories, exploratory projects in details, some words about our strategy for the future, and of course we're going to finish with the question sections. Okay, these numbers, I think they are from 2019, so they are basically the numbers for the design house. We have since 2014, we got 100 million reals, okay, of revenues. Our capex in that period was about 37 millions. So that's what's nice here is that we have 4 in this quotation in 2019 was about 4 million reals. Okay, we have this very nice number that's we got 11 tape outs since 2014. We have about 53 persons working in the design house. Okay, I'm going to talk a little bit more about this. And we are strongly oriented to produce publications. Okay, we have these research skills that we need to use it in order to bring more business, in order to show our works, and in order to attract the university to work with us. Okay, so since 2014, we had about 55 works presented in a conference, international conference. Some of those are national conference. We have 5 articles in journals and 1 book chapter. So these numbers, this slide is from 2019. Something changed here. Something changed for bad. Something changed for goodness. So, but it's more or less the numbers that people have today. In 2019, we had about 53 collaborators. So, but what really important in this slide is to show the importance of training people in Brazil. Okay, somehow we need to train people, and the message is quite clear. Everybody gets surprised with our infrastructure, our projects. Some people more impressed, some people less impressed. But in the core of it, we had this training thing. No, we had about 37 people trained in IC program. Okay. We have people from the PNM. Okay, we have some people from abroad. We got to attract some people from abroad. We had 3 doctors. Now we had 2 doctors only, but we had also these are CLT people. But we also have 3 postdoc that basically 3 of them. I think we have more, but 3 of them work with me. Basically, 1 is system design, 1 in telecommunications, signal processing, and 1 in IC design, especially mixed signal and especially mixed signal. Okay, so the message here is doesn't matter the names here. What matters is that in the core of our design house, we have this IC Brazil training competence that are quite important, not only for the other design house, but for our design house be what we are today. Okay, of course we lost people to that went out of Brazil, but what is important is that we keep the basis here, and most of these people are trained by this kind of program. Okay, again, the timeline of our design house. I think that's wrong. No, that's not so wrong. So that's right. So we had this PNM thing. We started this PNM training in 2002. Okay, and then we got some things about Eldorado on top, and something about the world here, the Brazil itself on the top. We'll have this SATEC, it's in Micron. The multi-laser start about 2015. So we have the CT2 that started its operation in Campinas about 2009, I think so. And then on the top we have our main achievement. So we have this SDBT nano 65 nanometers IC using a priority fund. Okay, it's about 2008. Our design house started being at the IC Brazil design house about 2010, I think so. And then we got some Ciprotec badges and some successful tape faults. We got some FunTech money to do the second implementation of SDBT 65 nanometers demodulator. We became a ERP unit in 2007, I think, 2017, I think so. And then got some deep submicron tape out with the idea. I'm not quite sure about this 7 nanometer, but I think it's also with idea of some companies. That is our partner. Okay, I'm not quite sure about this. Probably it's going to be clear later on. Okay, of course, I'm not aware of all the activities of Eldorado. I know most of it. I'm not the responsible of Eldorado. Design House Bertuzzi is our director. Is the executive in charge. But I have some information about this, all the areas. So I'm just trying to put everything together to understand how we work. Okay. So just a little bit more about our timeline. So yes, as I told you, we started in 2002 in our activities in microelectronics. It doesn't mean that we did not have interest or that some people did not work with that before, but that was our formal introduction here in Brazil in microelectronics with the PNM Training Center. Some people that works in Eldorado right now, they came from this first train, okay? And then we did this project IC Flow with Motorola. That changes its name to Freescale, okay? And later on changed again. So we got this project IMAX 700 and with the camp in 2006. So our things started here. At this time, I was not Eldorado. I came to Brazil in 2006, I think so, and then I was at IDEA, okay. And then we got this in 2008. Eldorado got this, gave some support to IDEA, a very important support in designing and in order to implement this SDBT demodulator. Okay, important message here is the first message is I was there. I observed the moves, and the message is we could not go ahead alone. Okay, Eldorado would follow his path, but maybe without this project, that it was quite important for IDEA, for Eldorado, the synergy between us. Okay, of course, Eldorado had another project with IDEA in all the areas, but that was more important. That was basically the most important project, quite recently, to the future of the design house that we have today. Okay, and for the future of IDEA, of course. That's my opinion, of course. But I was there. Okay. So we got the accreditation and official accreditation as design house in 2010, and later on in 2013. There was some kind of polemic things in 2013. We almost got out of the game here as official design house. That was really sad. But at the end of the day, we got the help of some angels to get into the boat again, and we kept our way going ahead and giving our best effort to the Brazilian microelectronics ecosystems. At this time, more or less, I was getting into Eldorado. Okay, basically, this first project was the DVB2 receiver together with the SDBT demodulator, and the second project was the IEEE 802.15 4G. That I'm going to talk a little bit more about this later on. Okay, so we started doing PADs in 2012, and we started doing Ciprotec projects in 2012 as well. Okay, and FunTech /BNDES in 2014. So I mentioned that was the MVP started in 2017, but here it's more accurate. It says it was in 2016. Okay. Of course, as you could see in the previous slides, we have really international level infrastructure. So this is a kind of picture in a glance about our capabilities of design. Okay, we have a capabilities of design front end. We do a digital design and verification. We do analog and mixed signal design. We also do some RF design. So DFT, do physical design. So in several nodes, as you can see here. So 108, 65 nanometers, 40, 28, 14, 7 nanometers. So I'm not getting to see here, but they are kind of remarkable designs. This was the first SIP made in Brazil. This was made with when I mean ours, it's ours and ideas ISDBT demodulator, together with this other elements in order to shrink the area of this IC, this combination. We are going to see why later on. I have a very didactic example of this. That was the first MCM project in Brazil. Our goal was to be a commercial MCM, but later on, for some reasons, the company that was contracting us gave up about this project. Okay, so we have this ISDBT 65 nanometers, 65 nanometers design. Of course, that's the base of our. Of course, our design house was born in 2012, but that could be a new rebirth of our design house. Okay, with a very important project that we're going to see later on. So more recently was capability together with Smart. Okay, of course, with the funding of Smart through several funding money, we got the package design capabilities. We are capable of doing package layout design. We do signal integrity evaluation, power integrity evaluation. We can have a very interesting facility, lab facilities for thermal and mechanical analysis. Also, with simulation as well. Sorry, we also can do package reliability predictions. More recently, with together with IDEA, we got this photonic package design capabilities. I'm gonna get some details of it later on. We also got this AT program design and much other things. So here on the border, we have this very nice project that we have made with PTech. It's a small company here in Campinas. This is called the project PM3GA. That's basically on this part here, we have the sensor that we package, we encapsulate Eldorado, and here we have some boards of signal process and data processes that we have designed. Okay, I'm gonna give some details. Okay, here it is. So basically, I'm gonna put that back. Okay, this project is the serious X-ray microscopy project. So this is the head of the sensor that captures the data, and this is the board that captures the data transferred to our main processor. Okay, a quite important project made by our design house, along with PTech. We have a lot of tools that work at our design house. Of course, we're just talking here about the tools used in the design process. Of course, we also use free tools like Octave, GTL, Python, all that stuff. But we have the main tools in the markets, and so of course they are here. So let's talk a little bit about our design house test laboratory infrastructure. So the main goal here is to test the silicon that we produce, or silicon from other partners. Okay. We'll have a broad view of the things here. Basically, here they are mainly development laboratory. We have this a full anechoic chamber that can be used for certification, also for research. In the time he is not used for a certification process. We have on the bottom here, this is part of my lab. We have this capability of performing evaluation of implementations of communication systems. We have channel emulator, a lot of signal generator, so a state-of-art AWGN Here I have some development labs and testing labs. Okay. So mainly the goal of these labs is to qualifying tests like a JDAC. I'm not JDAC tests. So if I skip slides, so don't be worried. Later on, you can ask for me. If I cannot answer you any question, I can redirect the question for the people here at Eldorado. Of course, the presentation is going to be available later on, so we can go slowly through the presentation and see what you want to see better. Okay, but the idea here is to have this main overview about our capabilities. Okay, it's not possible to get in all the details. Okay, but we in this case we are just showing this capabilities of testing labs. We have for doing a JDAC test. We have several environmental chambers, the X-ray equipment to do some evaluation of soldering and bumpings. Okay. Have shakers, have drop tests, chalk tester, motorized test stand. So we have a very nice facility in terms of capabilities of tests, or qualification tests of silicon. And of course, also for other designs, okay, hardware design, conventional hardware design. So let's talk about our portfolio of design. Okay, of course, I'm not talking about everything. I'm talking about most of the things that I can mention. So there are some things that's not possible to mention to you guys. Okay. Of course, I should start with this ISDBT demodulator. So it's a project that has a lot of fathers. Of course, I'm really proud of taking part of this project. I'm really proud because it changed the path of Eldorado and idea as well. It was the basis for what the companies. I think so. I believe that that's the basis for what the companies became nowadays. Okay. Of course, there are other things the companies used to be what they are, but it's a kind of seed for this new phase of the companies. Okay, but we did this SDBT demodulator in 65 nanometers. Okay, it was using some products like this product that was made in partnership with Intel. Okay, this is a kind of PC stick. Okay, and our goal. So as I mentioned before, it's a kind of, well, I'm talking about not only the design, I'm talking about story. Things change in the story, no. So we did this SDBT receiver. It was 3 years ahead of what was in the market. It was a really nice project. And then we had plans for it in the future. So our future idea was to create the DVB-S2 receiver, that's a satellite receiver. And then our idea was to put together the DVB-S2 and ISDBT in a single chip in order to do to make possible the reception of terrestrial and satellite digital television. Okay. This is the idea through 1B. I call it DTV2 because it's we need to fix some bugs, minor bugs in the first version of the SDBT demodulator, and then we did this project with idea. Okay, if I'm not wrong, it was funded by Fontech or Cibatrack. I always mix the acronyms, okay. But if Bertuso is here in the presentation, he can save me in the question sections, okay, and put the right name on the things, okay. We also had this UHF RFID tag that was made using the Silterra 108G process. It's a 1 millimeter square footprint. This was encapsulation just for testing. Okay, very low. Of course, it's a very low power consumption project. I'm really proud because I took part of this project. I took part of this project at the very beginning. Of course, it's not about me, the presentation, but I really, when I do this kind of presentation, I really feel happy in seeing the things moving ahead, you know, even with all these issues that we face in Brazil. So it's really nice to be in a place that is standing, okay, and take part of this project. It's really nice for me. I'm really proud of it. I don't used to say that, but I'm really proud of it. I did not took part of the piece making, and I don't hope to use it, but okay. But this is gonna be it's a project that we made with Fontech and BNDES. It was sponsored by Baumer Biosensor, and we made in partnership with Incor as well. So we are I think that we are debugging this design right now, and our future capability is gonna be to add some implantable cardioverter capabilities. It's going to work also as a defibrillator and cardiac monitor. Okay. So that's funny because we have not funny actually. It's nice because we have a package research project that it's targeted to do a packaging with this IC. I'm sorry, and other stuff. No, to be implantable. Okay. It's just a research project right now, but I hope it gets into the market in the future. We had this legal metrology stuff that we started working several years ago, and in this context, we created several small designs, including this analog ADC. Including this analog front end and this 24 bits ADC, and also another 16 bits ADC using the X5 and using CEDA technologies. Again, about the Sun chip, that's why Sun chip. Why Sun is a technology devoted to originally devoted to smart utilities network, mostly for energy, but due to its capabilities, it's really considered to several applications in IoT and smart city. Okay, you can see later on. It's really flexible. It can handle data rates from 2K, about 2K with FSK, and nowadays up to 2.4 megabits per second use of FDM. That's quite robust under a multi-path environment. So in this Sun chip, we have a very nice publication score. We have 8 published articles, 6 patents in the pipeline. So we are planning a second tape out to December. Okay, I'm gonna give more details about this later on. Okay, all these projects have high synergy. So especially because they can the technologies can be combined together and to create new products. Okay. So more mixed signal IPs from Eldorado, so ADCs, and DACs and PLLs. Okay. So we need to talk a little bit about Eldorado as a service provider. Okay, we got this nice project with CPQD a long time ago. If I can say long, it's not too long. So this OTN project. I don't remember the node, but it was a quite nice project with CPQD and PyTech. We also got this PLL. I cannot mention I'm not sure if I can mention the name of the company, but it's an international company. We made this PLL for them. So again, also about being also about Eldorado as a service provider, we got this IC for artificial intelligence signal processing. Okay, we have this. I think that's a new project from PTech. It's 4P project. I cannot see this quite well. I think there's an evolution of this the previous PTech projects. So we see all the things that are playing an important role in the market. This is being used, I think so, in the synchrotron already. The new serious facility. So I have another. It's not about IC itself, of course, but they have some important things behind this. There are some important things behind this project. So, of course, we cannot just do the IC. We can test. We need to create. We need to offer products to our customers. We need to do some reference designs. And then here in this part, we have this HDMI media player using the chip, the SDBT chip developed by Eldorado and IDEA. On the top here on the left, we have this first Brazilian ultrasound platform. It was funded by FINEP. It was with the support of the Brazilian Minister of Health. It was made by the Eldorado with this Brazilian Association. I think the name is Brazilian Association of Ultrasound. Unicamp was quite involved in this. There are more other companies, but in this process we have a lot of signal processing, phase array signal processing, all those and other kind of signal processing. Also the hardware, the hardware, special hardware that was made for this ultrasound, the image processing. A lot of software and firmware was were implemented to implement this platform. It's a basic. It was a scientific platform that was supposed to evolve in other directions. I think that's. I'm not quite sure right now, but we have evolution in some directions. We're still using this as a base. It was a quite important project here at Eldorado, and of course, a lot of people from the design house work in the signal processing design, in this, and as well in the hardware design itself. So here again, this HDMI player. We have this voice gateway for cable TV network that is being produced at Manaus. We also have this snap. I think this got a prize for design. It was made for Motorola. I have some other example here, okay, but it's always connected. We cannot just do the AC without doing the complement. And as I shown before, Eldorado has a very broad capability. So the idea is to take these capabilities and using these different projects, of course, including the design house, as most of the people that work with those kind of design belongs to the design house. Okay. So a little bit about our packaging laboratory. Again, more fancy pictures. They are real, of course. They're not took from the internet, my friends. Very nice pictures about our facilities, some tests. So here's Eldorado again. Our lab, our current area is this area, small area here. It's not so small as in the picture. We are planning to grow a little bit. I think that's what we're gonna grow about 50% in the future. Not so far, I hope so. And in this facility, we have this DP class, inline class. That's a class for 100. Inline is a class 1000, and of course for the back end we have this class 10,000. Also have here in the end of the thing starting here and come up to here. This is the back end, and then we have this test facility here at the end. Okay, I'm going to show a little bit more about this. There are some pictures of our lab. I'm going to show some detail of it. This is the process. Okay, we have this flexible design flow. Of course, we can start from the wafer or from import the IC, and then we can do all the process all the way until the applications. Okay. Let's show a little bit more. So in this first area here, that's the die preparation. We have these machines. I'm not quite sure if all those machines are there. The people can correct me later on. If you have any question about this, I think all those are there. But if you have any question, just ask me later on, and then I will redirect to the guys that work with this in the design, in the package design, in order to solve your doubts. Okay, your questions. In the inline process, we have the die attach capabilities, wire bonding capabilities, the cure oven. We have this plasma cleaning and die attach machines. Okay. In the back end, we have this ball mounting, the compression molds. we're gonna see some design next. I have the package simulations, the laser marking, and of course the laser cut. You know, that's part quite clear to understand. You know? We have all this. If you have a group of memories, so we do everything together. At the end, we cut it and we mark this laser cutting. I think the laser markings here, of course, they wrote the product information, and they separate the product here. Okay. Here for sure, I know that we still don't have the FIB, but they are a part of our roadmap, of course. If they are not here nowadays, in the near future, we pretend to have all those stuff in order to increase our capabilities of failure analysis. But we have this capabilities of X-ray inspection. We have this for sure. This is stereo microscope for sure. I think we have this one, and FIB and SEM are in our plans. I think so. Of course, again, if at the end of the presentation, Bertuzos, Fernando, or Claudemir are around here, just make it clear for everybody. If you have don't have this, I'm sure that you don't have it, but this two I'm not quite sure. That's an interesting project. We started working with IDEA in this new IDEA phase on DSP for optical systems, and then we got this optical packaging capabilities. Okay, there's some information on this because I thought it was quite interesting. Okay, we have this capabilities of tactic die and bonded attachments, UV epox, ceramic with ceramic soldering. We have capabilities of passive components assembling, active components soldering. We have this accuracy of 30 micrometers to 50 micrometers with this temperature profile of 3 degrees. Okay, this is more or less the same, but this is quite interesting. So we have this hermetic sealing capabilities also. Okay, this assembly with pressure control. It's quite nice equipment. So a little bit about I'm not going to give some details about our roadmap. Our roadmap is quite aligned with the world roadmap on this technology. Of course, some of the technologies already exist, but some of those are not in the market. But this is just to see, just have an idea about how we work with these roadmaps in our design house, and of course in Eldorado as well. So this in the first year is we showed this technologies that we are capable of doing projects using it, or we just need a little bit of improvement. In the second to the third year, we have this technology that we need to get more in contact with. So we need to buy equipment. So we need to, but they are in our roadmap, and for sure we are going to achieve that. Because this is if you don't see the things in this roadmap way and plan it in a quite appropriate manner, we cannot achieve good results. Of course, neither for us or for our customers, of course. Okay, but like nowadays we have this SIP capabilities, we have this MCM capabilities, photonic integration, and package design and simulation. I'm going to show some fancy simulations on these multi-physical systems. Okay, and we have this kind of roadmap for all our activities. Okay, I'm just showing this roadmap because not so quite sensitive. Okay, because they are the technology that we are showing here. They are in the market, but we are just showing our capabilities, and some of those capabilities we already have, but don't have equipment. So we need to improve our lab and also our capabilities as well. And in the 4 to 5 years period, we have more advanced stuff to work with. Okay. Of course, we guys feel free to send email to me or to anyone at Eldorado to ask questions. And if you are interested to work with us, not work with us only, but do projects with us as well. So please contact us. Don't be ashamed. Don't be ashamed. So some more details about our projects. I have a lot to talk yet, but I'll try to be fast. Again, on some more information about the SDBT demodulator. So it has about this is the first version, okay? So I think we'll have information about the second version as well. It has about 45 to 75K code lines. It uses 65 nanometers from Global Foundries. It has about 10 million gates. The area is about 19.1 square millimeters, and it has 90 million of transistors. I put this slide here just because I'm gonna make some comments. Don't be offended, anyone here. When I got into the idea, before I go to Eldorado, I started this project. I was responsible for the system architecture of the IC, especially for simulations and modeling of synchronization. And at that time, it was really nice because I work with very bright people, and they really were quite well trained. But when I got that idea, they were planning to do this SDBT receiver, and most of the people were they had experience with data processing signal, okay, implementation. And then when you go into the signal processing area, there are a lot of other black holes that depends on other areas like communication systems. And even regarding communication systems, if you go to an ordinary, I don't mean a very mean course. I mean very nice course like at Unicamp and other federal universities, also at the University of São Paulo, at my university, at my alma mater, UNESCO. So most of the course they don't take, they don't train too much people in synchronization issues, no. Usually the people work with a very simple VTEP decoders, maybe in the master's degree or PhD. The people get more into get in a deeper manner in some of these blocks. But usually the synchronization is really a tricky thing that's not well taught. And then when I was there at the idea, I figured out, oh, the people is quite good, but this is not IC design. This is a telecommunication system design, you know. And that was one of the lacks in the IC Brazil. I almost did not get a scholarship because I had a lot of experience on this, but less experience in microelectronics. So you see, if you don't see the big picture, it's really difficult to draw a very nice program, you know. And this is a remarkable design in our IC Brazil program and in our PNM, in our microelectronics program. But part of it was not covered by our design process, you know. So this means that we need to create people too. So in this, I'm really proud because I helped to train a lot of people on this part, okay? I really need to mention that because it's a really important part, and it was not covered initially by the IC Brazil program because it belongs to another field, you know? Okay, it was the first commercial integrated circuit development in Brazil using 65 nanometers. We are about 3 years, as I told, I had the market. Its strength, it was the aim was to strengthen the local microelectronics system and increase the international competitiveness of Brazil. Okay, it helps a lot, but unfortunately, even with these improvements with the second version, okay, we did not were really successful as we planned at first. For any reasons. So I'm not planning to mention the reasons, but I can mention one of those, that when the people made the call for the low-cost Brazilian set-top box, they considered a lot of technologies to shrink the price, the price, not the price, to be accepted as an enabler for the people that apply to the supply proposal, but they did not consider the core of the modulator that was the ISDBT demodulator. So without that requirement, we were out of the game, because the people could use any ISDBT demodulator from any company in the world. At that time, the price was quite good, yeah. But after that, the price started shrinking. And so the Chinese started doing more design and cheaper, and then we lost the track. And of course, okay, that's what I can tell for now. So if you have any questions, we can talk later on. But it was really important. It is a really important example of design made in Brazil that cover a lot of areas, synergy between companies, that's really nice. So okay, so and then we made the first one. We did this design to prove to a possible customer that was possible to use our ISDBT receiver in one of them computers. The idea was to put this design in the board, okay? But as you can see, it's a quite huge design, of course. But this one was just used for prove the concept. And then I think that Pertuzzi came up with this idea of doing this MCM, okay, in order to put together the tuner, the PCI Express bridge, of course, and our SDBT demodulator. And then we create this MCM, of course, and then we create this new board just to test most of this electronics to give power supply and other filtering capabilities, like and clocks as well. But there are not too many compared to the previous design. Okay. Okay, guys. The people was asking me to accelerate. Okay, I'm just gonna skip that. I'm just showing that this thing is shrinking until we got this second version of the SDBT receiver. These are some equipments that we have used to test in the real world capabilities of our IC design. Okay, again, our RFID chip that I already mentioned. So, as I mentioned before, our idea was to put together the SDBT receiver and the DVS2. In this end of this year, we're gonna prototype this tuner that has capabilities of working with L-band for satellite and also for terrestrial signals. And we're gonna test it with our DVS2 and probably with our SDBT receiver. Okay. So this is one more example of how we design things. We do from zero. We do all these synchronizations, simulations, and all this LDPC, VCH decode and simulations and implementations. It's quite inside each one of these blocks, there are a lot of blocks, you know. It took a long time to get this. This is just a exploratory design. This is a more overview of our DVS2 receiver in order to see, to verify if it was available, was viable to implement it in ASIC. Okay, the design is ready, it's working, but we still don't have plans to implement it soon because it costs a lot to implement it. Okay, this is the White Sun chip that has the last version. The last version we will have the 3 modulation, but we decided to just have 2. This GFSK and OQPSK. The version that we're going to implement in the end of the year, it has a GFSK and OFDM. It's a very complex design because it has 2 moldings. This means that you have a modulation, the modulation, synchronization for all those modulations. But we also have the OQPSK work in FPGA. We are still deciding if we're going to put it on the some implementation in the future. This is the for planning of RIC. It was made in partnership with Unicamp and the University of São Paulo. I'm not going to mention the name of everybody, but there are someone that was at the University of São Paulo, that was Lucas. That is Unicamp right now. He made this baseband processing. So I have some guys, Artur made the ADC. We have Pedro Paro that made this our digital transmitter. And we'll have the people at Eldorado that made this. Julian Eldorado from Eldorado did the RNA, and my guys did the mode, just the mode. it's just higher, just molding. Okay, in the end of the year, it's gonna have OFDM as well. Okay, there are a lot of applications, as I just told you, for this kind of technology. Okay, it's a kind of enabler. I'm not gonna talk about Lego. Okay, the ultrasound again is just a overview. Okay, you have some simulation, some capabilities of simulation of multi-physical systems. We'll have this thermal dissipation and hotspots on the die top. This is a stack of memory. Okay, memories. We'll have this MCM for our PC maker to evaluate the normal hits behavior. Okay. Okay, one more. The mechanical simulation of ball bonds, of wire bond. These were all those simulations were made by I think that's Jose Ramirez with the help of our other guys in the packaging lab. So another nice simulation on the mechanical flip chip simulation with gold bumps. Okay. Okay, that's really nice for microfluidics. It's about thermal dissipation using fluids. Okay. As I told you, I'm not gonna give details because we are running out of time. Okay. Okay, a little bit about our strategic vision. So our DNA is obvious. So we are a kind of a ecosystem enabler. So we were born as a design house to fill in the gap between the universities and the companies. It doesn't matter if they are big companies or small companies. Okay, but our DNA shows us that we need to take technology, and put it in the market. But how? We need part of it is made by us, and part of the technology is created by universities or some partners. We take this. We use a mechanism to decrease the risks for the company, and then we make these the companies that are not want to take too much risks. I could say no risks, basically, but the idea is to make the technology more acceptable for those companies, because once we absorb part of the risks, the risks decrease for the companies, and of course the technology becomes more attractive. Okay, this is our DNA. We are here to fill in this gap. Okay, but how to do it is a game. So about new opportunities in microelectronics, basically, it's not in English, but I'm sorry about that. Okay, but it's we see these 5 areas as are important. There are other areas, of course, but we see that these areas are quite important, are going to play a very important role in the future of Eldorado Design House. It's about the first one is about high temperature electronics. Okay, for a lot of applications like gas and oil, industrial applications, automotive, and aerospatial. Microfluidics, of course, it's quite clear the need of microfluidics. So even for the people that start doing design for chikungunya or for other illness, now the design is moved to COVID. In the future, we don't know. I hope we don't have another illness like this COVID. But technology is here to help us. Okay. We also believe that specialized training is the future, because with the loss of the training facilities in Brazil, we need to create specialized training. Otherwise, we are gonna die in the near future. Okay, so we need to do this with universities and of course with other partners. So we also are gonna play a very important role in this production of low volume, like in our package line, like we can package sensors and all that stuff for IoT. And then we are really beaten in. We are really expecting that we are exporting sales increase significantly. Okay, and then we are going to work for that happens. Okay, so we have 2 main strategic goals. We have other goals, okay, of course, but 2 main strategic goals for our design house are to achieve international competitiveness. And how we are going to do that? By means of structuring a global network of partnership, strengthening our skills in high impact areas like project management technical design. We also need to further improve our skills and have more competitive portfolio in the mixed signal and ultra low power. We need to invest in improvement of areas with low global supply, like DFT, high voltage design, high power design. And of course, it's really paramount to stimulate the culture of innovation and to preserve the intellectual property, okay? So, okay, also, in order to achieve, okay, I think I just skipped that. It's missing one slide. Okay, so for last but not least, I need to say some words about MVP units. Our MVP units is really important for us because it's helping us to decrease our dependence on the ROI and PEDs, and make more feasible some projects. Okay, our main idea is so simple: get all the competence that Eldorado has in hardware design and create and help our customers to create products. MVP is really focused on bring technology in the form of products. So the basic rule is 1/3, 1/3, 1/3. It's not exactly like that, but the main rule was MVP comes with 1/3 of the money, Eldorado is 1/3, and the company comes with 1/3. This varies a lot, but of course, Eldorado does not have a lot of money to invest on it. So usually we put less money than that, and the companies, MVP always put 33.3% of the money, and the companies put more or less depending on the project. Okay. Okay, I think I got into the end. I'm really happy to make this presentation. I'm sorry if it was not clear because there are a lot of subjects to talk about it. But my idea, as I told you, was to show a little bit about the story, a little bit about our strategy, a little bit about our designs, and to be as open as possible. And my personal message is that we are not going to be successful alone. We need to be successful together. We need to find a way to cooperate among us in order to make our microelectronics ecosystems as strong as possible. We know that we are losing some wars, but we need to keep our heads. We need to keep standing and follow with our goals. Okay, guys. So thank you again, Professor Reis, for inviting me, and thank you all the people from Eldorado. Fernando, Dario, Bertuzzo, Ricardo Choca, José Ramírez, Claudemir, Rodrigo Fioriti, Rodrigo Salles, and I'm sorry about the other guys. Thank you very much. I hope it was nice presentation for you guys, and it was helpful.
Okay, thank you very much, Eduardo. So time for questions. So if you have any questions, you can do using the chat of the YouTube. So I have one here by Professor Jacob Swart. So about the X-ray sensor for Sirius project, does it contain an ASIC designed by Eldorado, or will it has one in a future version?
I don't know if we would like to have one in the future version, but the ASIC was one is concern. I think this, because I did not mention that because the screen is quite small here for me, and then I cannot see all the letters. But we have used this CERN sensors. But I hope in the future we do that. Basically, our work was integrate everything for PTech and for the LNS. Okay.
Okay, so I have a question. How many people you have working on IC design?
I think now we're about we are something. I did not get that number, but we are about 45 and 53 because we lost some people last year, but we have a lot of master's students and postdocs work with us. So this means that we lost some guys, but we got some other designers from the university. So we kept more or less around 50 persons working straight with the design related thing, you know. In packaging, digital design, analog design, mixed signal, etc.
Okay, thank you. So another question is, you saw about the design of the pacemaker, no?
Yeah.
So
No,
this is still using a battery, or it's energy harvesting?
as I told you, I'm not aware of all those information, but I believe it's in this version is using a battery. But I saw some people working in this energy harvest stuff, but I'm not quite sure. I can the person that asked that can send me the email. You have my email right here. Are you okay? Okay, I will. If Bertus is here, he probably can answer. But I can send you the information. As I told you, I'm not the I'm not the head of the design house. I just
it will be great to have a version using energy harvesting, avoiding to do a new surgery to change the battery.
Sure. But I think that people is really considering that. We are working on a new version of the SIC for soon, I think so. We just hired some new guys to play with that, and I hope to see this new version. Of course, we are looking for the new partners to come into the game also. It's always important to have a new partners.
Okay, thank you very much.
To make this kind of design feasible for the world. But I'll see you later on.
So thank you very much for attending this industrial talk today, and thank you again, Eduardo. Thank you very much, and good evening or good afternoon for everybody. Bye-bye. See you next Friday, beginning of the afternoon.
Thank you, guys. Thank you. Bye-bye, pessoal. Tchau, tchau.